And finally, Docker. Docker is a huge subject. You could probably work on some project involving Docker for months and you'd be still learning new stuff and ways to optimize things. The way I'll approach this subject is I'll introduce you to some basic concepts. What is Docker? What are containers? What are Docker images? How does it all interconnect and why would you want all that? And then we'll build on top of that when we start deploying containers. We'll install Docker daemon with a custom configuration, and we'll also install Docker Compose for multi-container deployments. But before we start with that, let's see how all this Docker stuff work. So what is Docker? It's not easy to explain that in a single video, but in simple terms, it's a tool that enables you to deploy your application in a predictable manner and in a level of isolation that you define. Let's explain some basic Docker terms. First, we have a Docker daemon. Docker daemon or engine is what you run on the server where you wish to run Docker containers. It's running as a service and listens for API requests from the Docker client. Docker client is a command line tool that you use to interact with the Docker daemon. This Docker client is not something that is locked to the particular Docker daemon. You can use Docker client to communicate with multiple Docker daemons on different servers. If you are on macOS or Windows, you probably want Docker Desktop. It's an all-in-one application that will set you up with Docker daemon, Docker client, Docker Compose, and a few other things. When you use Docker, you are manipulating so-called Docker objects, and most important ones are images, containers, networks, and volumes. Docker image is a template for creating Docker container. It's a set of instructions for how to create an environment where your application can run. Image has a name and a tag. You can think of a tag as a version for that particular image. So something like MariaDB 10.7-focal will tell you that this image will provide you with MariaDB version 10.7, which sits on top of Ubuntu Focal, which is Ubuntu 20.04. Looking at this focal part, you might realize that you can have different starting points for your images. Remember that part. By using images, you can be sure that what you are deploying is always in the same predictable state. Every time you run a container using this image, you can be sure that it will produce the same result. One way to get a Docker image is from a so-called Docker registry, and the official one is located at hub.docker.com. You can also self-host a Docker registry, and there is also one you can enable inside GitLab called GitLab Container Registry, but more on that later. Let's search for MariaDB here on hub.docker.com. Here is the official image. Click on that. And if I scroll down a little bit, I will find 10.7-focal. Let's check it out. What you see here is a definition for this image. You write that definition in a so-called Docker file. You should check out Docker file reference page for all available commands, but in a nutshell, you have some starting point. In this case, it's Ubuntu Focal, and you build upon it. You are adding layers on top of that starting point with each new command. Here they are adding a group and a user, they are updating the system, installing some packages and so on, and finally they run MariaDB on this exposed port. You might be wondering where does this Ubuntu Focal comes from, and every time you see this from, you know that it references another image. So if you go back to the hub.docker.com and search for Ubuntu, here is the official image, and if we scroll down a bit, we will find the one with the tag focal. And if we click on that, we will see its Docker file. this one starts from scratch image. That is a special reserved image used when you need a clean starting point. And the only thing they do here is they copy this tar archive, which is essentially the file system for Ubuntu Focal. And in the end, that's what images are, a file system configured in a way that suits your needs. Another way to get a Docker image is by building it yourself. And you do that by writing your own Docker file and issuing a build command to the Docker client. When done, that image is only available on the system where you issued the build command. If you need to run it on another system, you have to move it somehow. While you can just copy it over, you probably want to store it in a registry, and you do that with a docker push command. On another system, you can then pull that image and it will be available for use. Using a Docker image, you spawn a Docker container. Container is an instance of an image. A container has a life of its own. You can start it, stop it, remove it, or even create a new image from the container's current state. When you remove a container, anything that is not explicitly saved in persistent storage disappears. Containers can run in a complete isolation. You can run them in a way where they share a network with the host system or maybe with another container. You can also run multi-container applications using Docker Compose. Docker networks are software-defined networks which enable you to configure how your container communicates or doesn't with the outside world. You can choose different network drivers depending on your need. There's a lot of options here and it gets overwhelming pretty quickly, but I'll talk more about it when we deploy some applications. Volumes are what you need to use if you want to persist data after a container is gone. So for anything that your application is generating that you wish to keep after a container is gone, you want to set up your application so that it saves the data in a Docker volume. Then, if for any reason your container is killed, either on purpose or due to some crash or reboot, the data which was saved on a volume will still be available. To recap, Docker daemon or engine is running on the server where you wish to deploy your containers. Docker client sends commands to the daemon. Docker images are templates from which you create containers. You can get those from Docker registry or by building your own with the help of the Docker file. Containers are instances of an image and you define how they will run. Completely isolated in a shared network with other containers or maybe with the host system and so on. Docker networks allow you to architect your setup the way you want, who can talk to whom, which containers can access the internet, etc. And Docker volumes are used if you want to persist data after a container is gone. I know this is a lot, but don't get intimidated if it's not all clear yet. That's completely normal. We'll be doing a lot of Docker stuff and it will get better, I promise.